Hi everyone. Today I'll be going over my OChem homework. So hopefully this will help some of you guys out. So let's work through it together. So we're starting with the first problem. What's the parent chain of the following compound? So I'll take this and then let's put it here so we can work on it together. So parent chain, we want to figure out what the longest chain is of carbons here. So let's start doing that. Let's use our highlighter tool. So let's say I want to start here. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, no. No. Okay. So as you saw, I tried to go through and basically figure out what the longest parent chain is by just picking a random spot to start at. And it looks like to me the longest parent chain here is this. So let's see how many carbons we have. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. 9 has the prefix non, so nonane. Okay, and it doesn't really ask for the entire, it doesn't ask for the molecule name, it's just asking for the parent chain. So the parent chain would be nonane, and we're going to check our answer right now. We're good. We're going to move on to the next one, okay? So now we want the IUPAC name for this compound. So let's do that together. So let's make sure it's on here. Let's make it bigger. Okay. For IUPAC, you want to start with the parent chain first, right? So let's figure out what the parent chain is. So we're going to use yellow. 1, 2, 3, 4, 5, 6, 7. Okay. What if I started here? 3, 4, no. 1, 2, 3, 4, 5, 6, 7, 8. That one's 8. 1, 2, 3, 4, 5, 6, 7. 8 is more than 7, right? So let's do this again. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay. So that looks to me to be the longest carbon chain we have here. So it looks like that. So now we've identified the parent chain has 1, 2, 3, 4, 6, 7, 8 carbons, right? So for 8, I'm going to say parent chain is equal to 8 carbons. And 8 has the prefix octane. Let's make sure we have that. So it's the prefix octane. Sorry, it's the parent chain equals octane, right? So now we need to figure out the substituents. Okay, now that we have the parent chain, let's go to substituents. So we can either start this as 1 or we can start this as 1, right? So which one is it? we need to figure out what's closer to the first substituent, right? So let me remove all these numbers and we'll take a look at it, okay? Remember, this is the parent chain. So if I go this way, 1, 2, 3, I get my first substituent, right? 1, 2, 3, I get my first substituent. So in this specific case, this is a methyl and this is a methyl. So it really doesn't matter where you start. It's the same on both ends. So you can call this 1, 2, 3, 4, 5, 6, 7, 8, or you can choose to call this 1, 2, 3, 4, 5, 6, 7, 8. But either way, it doesn't really make a difference. So now that we have our substituents, we have, I'm just going to go from here. You can do it from the other side, it doesn't really matter. So 1, 2, 3. So you have 3 methyl, okay, 4, 5, 6, 6 methyl. Okay, so now that you've identified all the substituents in this group, then you can put it together. So let's do that. So how do we put this together? So first thing, 3, 6 dash dimethyl octane. Okay, since you have 3 and 6 both have a substituent at that point, right? So that's why you write those numbers down. You take it from here, right? So now you have 3, 6, and it's dimethyl because there's 2 methyls, right? One at 3 and one at 6. So some of these are just rules that you do have to learn, but this would be what you get once you put it all together. So if you read it like this, you have an octane, so you can read it from the back. You have an octane, which has 2 methyls, one at carbon 3 and one at carbon 6. And then it's right there. There you go. Perfect. So let's move on to the next one. Okay, so this one's asking, I'm going to move to this side of the page. Let's make all this smaller. Move this stuff off to the side. So now we're looking at constitutional isomers of C6H14. Okay, so 6 carbons, right? 6 carbons, 14 hydrogens. So first thing you have to know what a constitutional isomer is. It's same molecular formula, different connectivity. So, well, it'll be easier once I show you what these examples look like. So this is your molecular formula, right? C6H14. So all it's saying is that you have 6 carbons and 14 hydrogens, right? Doesn't tell you anything about how they're arranged or how they're connected to each other. Let's see what this says. So which ones represent constitutional isomers? Let's do hexane, right? What does hexane look like? 1, 2, 3, 4, 5, 6. So hexane has 1, I apologize. 1, 2, 3, 4, 5, 6 carbons. Each of these has 2 hydrogens. 2, 4, 6, 8, 12, 14. You have 14 hydrogens, okay? So this would be one constitutional isomer, C6H14. This is a ring form, so this would be a cyclohexane, okay? The problem over here is saying normal hexane, right? I just wanted to show you that there's cyclohexane and there's hexane. Okay, let's show you what hexane looks like. 1, 2, 3, 4. This is hexane. This is cyclohexane. This has a formula of C6H14. This has C6H14. Why is that the case? Here, 1, 2, 3, 4, 5, 6. 6 carbons, right? Let's draw them in blue. These lines are going to be hydrogens, okay? And then so you can count them: 3, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is also C6H14. So this is just one form of a constitutional isomer where you have the same formula for both of them, but completely different arrangement of molecules, right? Hopefully that makes sense. And I just wanted to add the cyclohexane just to show you that it could also be in a ring form. It doesn't have to be like this. So for this problem, we have, it's asking for constitutional isomers. So one of them would have to be hexane. So hexane, okay? And then we have 2-methylhexane, okay? So just, let's see what that looks like. So 1, 2, 3, 4, 5, 6. Okay, this is hexane. We agreed upon that, right? So this is saying there's one more methyl here. A methyl has H, right? It's a CH3 group. That's a methyl, okay? So if you add these 3 extra hydrogens and you have 1, 2, 3, 1, 2, 1, 2, 2, 3. So keep in mind, 1, 2, 3, there's also a hydrogen here. That's because of octet. If you take a look at this carbon right here, it's bonded to 1, 2, 3 groups. It needs one more to fulfill octet. That's why you have that hydrogen there. So now we have 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This would be C6H16. So that is not C6H14. So this is not a constitutional isomer. This is a completely different molecule altogether. Okay, so now we know that 2-methylhexane is no good. Okay, so we could do 2-methylpentane. Okay, maybe that one works out. Pentane just means 5, right? 2, 3, 4. So you can think of a pentagon, right? It has 5 sides. So this is 2-methylpentane. So let's draw out the methyl. Let's do it in black. Okay. Remember, 3 hydrogens. Two. Okay, how many hydrogens are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Remember this. Okay, 3, 6, 7, 8, 9, 10. Sorry, 3, 6, 9, 10, 11, 12, 13, 14. Okay, there is 14 hydrogens. How many carbons are there? We need to make sure, okay? 1, 2, 3, 4, 5. Oh, there's only 5 carbons. Well, there's a carbon here because it's a methyl group, right? So this is C6H14. Because this is a carbon, let's draw it in a different color. There's a carbon here. Here, I'll do it in red. Carbon here and carbon here. That's where you get your sixth carbon from. So now you have C6H14. So 2-methyl pentane I works. Okay, so this works and this works. So we already have 1 and 3 are possible options. Okay, so now we need to figure out, we already figured out 2 is not it, right? So we crossed out 2. You can go through the process of elimination, but I'm just going to work through all of them just to show you what they look like. So now we're going to do 2,3-dimethyl pentane. So I'm going to make the assumption that this is not going to work, and then I'll show you why. So remember, 1, 2, 3, 4, 1, 2, 3, 4, 5. 5 carbons, right? You have a methyl at carbon 2 and a methyl at carbon 3. So I'm not going to draw out the hydrogens this time. We've done it 2 times. I want you to try to practice this on your own, so you'll get the gist of it as well, okay? I'll just write the number of hydrogens there are. And I'll draw this one and this one, just so you don't forget those. So there's 3 hydrogens here, 3 hydrogens here, 3 hydrogens here, 2 hydrogens here. So 3, 6, 9, 10, 11, 12, 13. 13 hydrogens, right? No, we're missing 3 hydrogens here. So the actual number looks like this: 3, 6, 9, 10, 11, 12, 13, 14, 15, 16. This has 16 hydrogens. So even without looking at the carbons, I already know that this is no good, like I said in the beginning, right? So 1, 2, 3, 4, 5, 6, 7. 7 carbons. C7H16, right? Ignore this part. C7H16, that's not a constitutional isomer, that's a completely different molecule altogether. So let's move on to 2,3-dimethylbutane. So that's V2,3-dimethylbutane. Okay, butane is 4. 1, 2, 3, 4. 4 carbons is butane. So if you don't know the prefixes like butane, methyl, ethyl, etc., I'll try to put it in this video. Okay, so in a few seconds it'll pop up and you can take a screenshot of that. Okay, so let's work through this one, right? 2 and 3, so carbon 2 has a methyl, carbon 3 has a methyl, right? And it's a butane. So again, we're not going to draw the hydrogens. I'm just going to draw the ones that are a little bit weird, right? So I'll draw this one and I'll draw this one. So now I want you to figure out, you can always pause and figure it out for yourself, and then you can come back and check. So 3, 3, 3, 3. Okay, 3, 6, 9, 12, 13, 14. Look at that, 14 hydrogens. And how many carbons are there? So 1, 2, 3, 4, 5, 6. 6 carbons. Okay, that's another constitutional isomer. So now what's the answer? So we said V works, and we said 3 works, and we said I works. I apologize, I don't know my Roman numerals 100%, but I believe V is 5. I could be wrong. So let's take a look at our answer choices. We said 1, 3, and 5. There we go.